Okay, hi and welcome to video notes 9.6 and 9.8. 9.6 is, remember, it was that X thing that we did. But now that we're into this, notice what we're really focusing on with our factoring today. Factoring, remember, factoring is division. And so if we're going to divide there, we're going to focus on trinomials or quadratics that don't have an a value that's 1. But let's go ahead and recall, though, what that looks like if we did have one that has a value of 1 like we do here. So here's an example real quick, just to review. You make a nice little x. You take a times c, right? A times c is 1 here and 6 here. You multiply them together, that's 6, and then they're going to sum to 7, which you put in the bottom. So a times c goes on the top, b goes in the bottom. Then you list out your factors. What factors do you have? And those combinations of those two factors have to add to this middle bottom piece here. So the ones that work here are both addition and additions of 1 and 6. They're going to multiply to make 6 and add to make 7. That's your goal. Multiply to make the top, add to the bottom. And then you go ahead and write it right into factored form. So you've got two binomials right there ready to multiply back out and make what you need for your polynomial. All right, so let's look at one that doesn't have an a value of 1. It kind of partially did this for us. We'll finish it up from here, though. So let's scoot over to this one. We've got 2x squared plus 11x plus 12. So taking that, if we follow our x, make our x here, multiply a times c, so 2 times 12 is going to give us 24. I have to add to 11, and that's our b value that goes in the bottom. Remember to write a, c, and b to remind you so you don't forget and mix them up. All right, so then we would go over here and make some factors of 24. Listing all the factors of 24, we're looking at all of these. There is a combination of them that will get us to 11. It looks like 3 and 8. So let's pick those. So now that we've picked 3 and 8, we're going to have to add them together, right? They both have to be addition to make that work. But before, we would just throw down some parentheses, put our variable in front, and put the factors behind it. Problem is, this is different. This now has a 2 in front of it. Well, let's pretend that we just take a 2 and an x right there, and we'll put an x over here, because it has to multiply to 2x squared, so I'll do it that way. But let's put in our factors. Let's put in plus 3 and plus 8. Let's check this, though, because I have a sneaky suspicion that it might not work. So if I go ahead and take 2 times x, like we said, we're going to get 2x squared. That's great. That works. Then we're going to take 2x times 8, which is going to give us 16x. And all of a sudden, we're feeling a little queasy because it wasn't working quite the same there. So 3 times x gives us a 3x. And then 3 times 8 gives us 24, which we're way off course now. Because this, originally, if you look back up here at this one, was the same value if we multiplied that out as the original. We didn't multiply that one out. But this should be 12, so we already have an issue. That one's not matching appropriately if we were to look at that. So we need something else. What we need is 4 terms. Remember, the x does give us 4 terms, so you can see that where we got those middle term broken up, that's where the 4th term comes from. We didn't explore that a lot, but it does give us 4 terms. We also need one other trick, which is this. We need grouping. All right, so let's pause there and talk about grouping. So grouping is just a general way to talk about factoring ones that have an a value of 1. What we're going to do, and this looks tricky at first, but you'll get the hang of it pretty quick, I promise. So we're going to take the polynomial, we're going to break it up into groups. Each group will have 2 terms. This is where the 4 terms come into play. So we need to take that x and break it up into 4 terms, and I'll show you how to do that. After that, we'll pick 2 terms at a time, and we're going to make 2 groups. We're going to G.C.F each group. That's our G.C.F number 1. What should happen at that point is that we should have a linear binomial pop out that's the same in both groups. If you don't get that, go back to the top and start GCFing again because you did something wrong. But if we do get a linear binomial that pops out and same in the 2 groups that we just GCF'd, and I'll go, it's very abstract right now, we'll put some concrete to in a second. Then we're going to GCF that linear binomial out, or our second GCF, and what happens is it's factored. It's like magic. It looks like a crazy pattern. Don't memorize the pattern. What I really want you to memorize is this, okay? Make sure that you know this well, because you need to understand what you're doing, because I'll give you tricky ones where you won't be able to use the pattern, okay? So let's take a look at one right now. Okay, so if we look at this polynomial here for us, it's already broken up into 4 terms. I took that part away. We'll do that in the next example. So you can see here, we've got 4 terms. You can technically put them in any combination you want. Use the commutative property, rearrange them. But if it's in standard form, just take the first 2 and take the last 2. It should work no matter any way that you rearrange these, okay? So looking at this red group, we're going to take the GCF of these 2 terms. Now remember, the GCF is a combination that we can divide out of the coefficient and that we can subtract out of the exponents of the variable. So in this case, 5x is our first GCF for the red group. The blue group, though, has a different GCF. It looks like it's just 2. This one doesn't have an x, so we can't take an x. So there's our 2 GCFs. What we're going to do is we're going to go ahead and divide both terms by their GCF. Here's this part right here. Bingo. So we're going to go ahead and divide that. So if I take this 5x squared divided by 5x, and I take this 10x and divide it by 5x, this should turn into, right, 5x squared divided by 5x is going to turn into x. 10x divided by 5x is going to turn into 2. So this is kind of our remainder. All right, so this remainder here, and when we do that division, when we factor by GCFing, and that's just really what we're doing, this is GCF number 1, we have to put that back out in front, that GCF, so that we can multiply it back in and go back if we wanted to. Can't lose it, because if we drop it, we did something wrong, right? We're breaking a rule. So we have to account for it. So there it is back at the front, and we did the same thing for the blue group. We took and divided it by its GCF, so 2x divided by 2 is x, and 4 divided by 2 is 2. Then we put that 2 back out in front. We retain this plus all the way through so that we don't imply multiplication on accident, right? Because they're all added together. But look what happened. When we GCF those, we now ended up with 2 terms. They look funky, but they're 2 terms. 1 term, 2 terms. We had 4, we got it down to 2. That's fine. Here's that linear binomial we were looking for. Look right here. That linear binomial is the same between both groups. This is where the GCF factoring number 2 comes into play. This is a common factor between these 2 new groups that we made. So I've listed it here, GCF of x plus 2. It looks weird, you're not used to it, but eventually you will be. So that's fine. Now what we're going to do is repeat our process that we just did here. We're going to divide it by that GCF, the common factor between these 2 groups of x plus 2. So when we divide those turn into 1, those turn into 1, but we have to account for it. So we put it back out front, and then we write our remainder, which is 5x plus 2. 5x plus 2. Looks crazy, doesn't it? Holy smokes, it's a lot going on. But if you follow the steps and you stick to the steps, it'll all work out just fine. So let's do one. Are you ready? So we got 4 terms here. I'm not going to use colors. I'm just going to use one blue. But here are my 2 groups that I want to make. So the first thing I'm going to do is I'm going to write down the GCF of the first group. So 8x squared plus 6x. I can take a 2 out of both of those coefficients, and I can subtract 1x out. The GCF of the second group looks like it doesn't really have a GCF. 4 is not divisible anything with 3, and they both don't have an x. So I say the GCF is 1. That's fine. Don't let that fool you. It's good. So now we're going to take that GCF. I'm going to put it out front because I'm going to divide now these terms by it. So I'm going to take 8x squared divided by that GCF and plus 6x divided by that GCF. Okay, plus the GCF divided out of that one is pretty simple because it's 4x divided by 1 plus 3 divided by 1, which doesn't change anything. This we can go ahead and write as 4x plus 3. Nothing happened with that one. It's really boring division. All right, but let's go ahead and rewrite this one. So there's our 2x, that's our GCF. So 8 divided by 2 is 4, and subtract this x, the x squared by 1, right? So we're going to go down to x. 6 divided by 2 is 3. Carry down your plus. Don't forget your plus. And those subtract out and turn into 1. So this is what I'm left with. Each and every time you do your first GCFing of your 2 groups, this should be the same. That's your goal. If you miss something, or if their signs are reversed, you need to go back and look. All right, so now let's carry on. I'm going to change my color here so we can keep track. This is our new term. It looks weird, but those are our terms. And there is a common GCF, which is the 4x plus 3. So now we're going to put the 4x plus 3 up front because we're dividing it out. And we're going to put our remainder right in here. So our remainder then of this, right, will look like this. 2x times 4x plus 3 divided by 4x plus 3. those cancel out. Plus 4x plus 3, forgot what I was doing, divided by 4x plus 3. You can put the parentheses on there if you want. Those divide out, and that closes that group. So what's left in there? It's a whole mess of, the only thing left, and this whole piece turns into 1. So that whole piece turns into 1. What we're left with is 4x plus 3 times 2x plus 1. And that's your factored form. Okay? Let's take a look at one more real quick, because there's something to pay attention to over here. Is you got to mind the negative here. So in this one, same process. Notice that this negative here, I didn't group inside of it like this. And the reason for that is that this 4x term is really a negative 4x term. So I have to add a plus and take that negative inside that first term. I also don't want the first term in my group to be negative. So I went ahead out of the second group here and divided that negative 4 out. All right? So that's where that negative 4 comes from. What will happen if you don't take that negative out of that first term is that when you get down here, your signs will be reversed. That just means you missed a negative. So mind that part, same process, pause, review it. But there we are with part 1. I'm going to sit down and buckle up because we have a part 2 coming. Okay, so we're on the back side and we're going to do some examples here. Here's that one from the front page that we couldn't do because it needed a G.C.F.ing of it. So if we look at this, we went back through the process. There's that 3 and the 8 that worked before, right? A times C is at 24, add to 11. This time, though, instead of trying to go right into factored form, we broke it up into 2 groups. Well, we broke it up into 4 terms, which we broke up into 2 groups. And then in breaking that up into 2 groups, we went ahead and found the G.C.F. So if you look at 2x squared and 3x, what's common there? Just an x. And then we divided those terms by an x. So this went to 2x, this went to 3. Same thing happened on the back side, 8x plus 12. The only thing common there is a 4. We divided that by a 4, we divided that by a 4. And that's where the 2x plus 3 came from. And if you look carefully, there's that common binomial, that linear binomial that we're looking for. That got G.C.F'd out, that went to the front, and then the remainder is x plus 4, which is there. Now notice I didn't write all the steps out. Eventually, this is what you'll do. But in your homework for today, I do want you to write those steps out so you can see it like on the front page. Let's do one that's a little bit bigger and maybe a little more challenging. Make sure right here that you pause and write down these other 2 examples here. We'll come back to this in a second. We'll talk about that. There's something coming up for you. So looking at this one, I did cheat a little bit, left the factors of 60 there. We're going to make an x. The top of the x, we're going to put a times c, which is 20 times 3, or 60. In the middle, we're going to write the sum, which is 17. We need to find 2 factors of 60 that are going to add to 17. So I've listed out our factors. We have 2 possible ones. We have a 3 and a 20 that may work, and a 5 and a 12 that may also work. The problem, though, to make the 3 and the 20 work, this is where the signs become important. The 3 would have to be a negative. And you'll notice that if we multiply by negative 3 and 20, we'd have a negative 60 as a factor. And we don't. So we have to go with the 5 and the 12. So we're going to put positive 5, positive 12. That gives us our 4 terms. I'm really tight on space here, so let's see if we can make this work. All right, so I'm going to break this up into 4 terms. So 20, and I'll blow it up a little bit. I'll scoot in. So there we go. So 20x squared, this is the middle term broken up into 2 terms, plus 5x plus 12x plus our 3 at the end. There's our 4 terms. Switch colors. Now we're going to group. There's our 2 groups. Now we're going to G.C.F. them. So what's common between 20 and 5? Well, a 5 is common. Okay? So what's common between the x's? There's a single x we can subtract out, so we'll put a 5x out front. So 20 divided by 5 is 4. Subtract an x off of our x's, that goes down to x. 5x divided by 5x is 1. There's our plus between. Now we're going to G.C.F. this group. Common between 12 and 3 is a 4. No x's are common because there's only one x in both terms. So 12x divided by 4 is, a 3 is common there. 3, which leaves us a 4x. Now notice I looked over here and saw this 4x, and I noticed I had a 3x there, so I knew I had a mistake. That's kind of one thing you want to pay attention to. These parentheses when you're G.C.F.ing should be the same. All right, and 3 divided by 3 is 1. So there's our 2 groups. Switch colors again. Here is our new GCF term. Looks weird, but that's the term we're GCFing out. So 4x plus 1, we're going to write in front. We're GCFing it out. Now we have to write the remainders. This divides out, that divides out, leaving a 5x plus 3. And that's what it looks like. It's a lot of moving parts, but if you understand what we're doing, it's not terrible. It's just a sequence, a lot of layers, but they're pretty easy to follow once you get rolling. All right, so this example over here, that's just another one to show you that how we go back to a of 1 value. But we have talked about something kind of important here. The one thing that I haven't addressed in here yet is that we're not talking about GCF before we go to 4 terms. So far, all of the quadratic trinomials that we've done have not had a GCF. So let's do one. What we need to do is we're going to find one like this example 7 here. What this says is that we can see that 20, 80, and 35 all have something in common, right? They all have a value of 5 in common between them. We've not seen that before. So what we need to do is we need to divide out a 5 before we start this process here. So let's do that. So I'm going to look at this. The first GCF, if I take this whole term here and I GCF it, there's going to be a 5 to come out. And I'm going to reduce all these terms by 5. So I'm going to get 4x squared. I'm going to get 16x. And I'm going to get 7. Now, this 5, we can carry it with us or we can add it in on the end because it has to be there. Otherwise, it's not the same polynomial. What we're really going to do is 4-term the one on the inside. So we're not really going to pay attention to the 5 till the very end. So let's go ahead and make our x. A times c goes in the top. So 4 times 7 is 28. And then we're going to sum to 16. Okay, so that's what we're looking to do. So now we need to find the factors of 28. I'm going to just write 28 over here. I'm going to list the factors. 1 times 28. I'm going to have 2 and 14, of course. And it looks like 4 and 7 are about the only 3 that we're going to have in there, I think. So let's see which ones of those in any combination is going to make 16. And that looks like a positive 2 and a positive 14. So there's the 2 factors that we want to use. I'll switch colors here. So we're going to have a positive 2 plus a positive 14. Oops, erase there. Now we're going to break this middle piece up into 4 terms. So we're going to have 4x squared plus 2x plus 14x plus 7. So we just took that 16, broke it up into our 2 factors found by our x. Now we can proceed by grouping. Again, we're coming back to that 5. We're just ignoring it for now. We're going to bring it back in at the very end. So here's our 2 groups. We're going to GCF these. So GCF of 4x squared and 2x. Looks like there's a 2 in common and an x I can subtract out of there. So 2x is the GCF. 4x divided by 4x squared divided by 2x is going to go down to 2. Subtract down an x. So it's going to go to 2x. And 2x divided by 2x is going to turn into 1. I'm going to put a plus here. And again, I'm going to GCF these with a different GCF. Looks like 7's in common between both of those. 14x divided by 7 is going to be 2x, not 7, 2x plus 1. Again, what we're looking for here is that these linear binomials are the same. Now we're going to GCF again. Really, for the 3rd time, here's 1 GCF, here's 2 GCFs, and we're about to GCF a 3rd time, which is very possible that you'll do this on a few problems. All right, so this is our GCF, 2x plus 1. So let's write that in front. And then what's left over after these are GCF'd out is 2x plus 7. Now we bring back in the 5. So 5 times that, because this, the blue pieces represent this. And that 5 multiplied in goes back to the original. And that's how you get there. Now, if you forget to take the 5, you may not find that it's factorable, or it gets real weird. So that's a good clue to go backwards. If you're noticing that this isn't working as smoothly as it should, go back and check for a GCF at the start. That's always something that we forget to do. All right. The rest of the examples are ones that you should be pretty good okay with. This one's another negative one, so pause and look that over. Notice how I took that negative, when I broke it up into a negative 10 there, plus a minus there. It's the only time I like to do that, so that I could regroup those. So check those out, and notice that if you can't find 2 factors, that will multiply to whatever and add, multiply to whatever the value is. That should be a, sorry, I changed this problem so it's not factorable. So that should be a 26. And there we go. So if you can't find 2 that'll multiply to the value that you want and add to the sum, which is 6, if none of these work, then it's not factorable. And that's plenty okay. It just means that there's a different way to get to it, but not this way. All right, so I think we're all done. If we look back and look at what we've done, we've checked out that we need to make sure that we GCF at the 4 terms before we start our process, right? We have looked on how to group, right? So we're okay with the grouping where we double GCF. And then if we go back a level, which I can't do right this second, if we go back a level, we've also covered how to turn it into 4 terms effectively and making sure that we mind the negatives by plus a negative there. All right, so at the end of the day, you should be able to factor ax squared plus bx plus c type using grouping, right? And you can also, again, reinforce the fact that we can change it into 4 terms. All right, thanks for watching. I'm out of here. We'll see you next time.